Right, today's lesson is on electric field strength in radial fields, and you'll remember that we looked at electric field strength in uniform fields in the last video. So we are now going to look at around a spherical charged particle, basically. So we're going to start with the definition of electric field strength, which we did look at last time. The electric field strength is defined as the force per unit charge acting on a positive charge at a point in a field. And the equation for that was E equals F on Q. That should have been a Q. I wrote a D, it should have been a Q. Okay, but we've got it right on this slide. So we know that E equals F on Q. We also know from the lesson before, Coulomb's law, that F equals 1 on 4 pi epsilon naught QQ over R squared. So if we take that equation for F and divide it by Q, we get E equals 1 over 4 pi epsilon naught Q on R squared, which is basically everything you need to know for this lesson. It's the equation for electric field strength in a radial field. We can compare it to the equation for gravitational field strength in a radial field. So you've got the constant 1 on 4 pi epsilon naught is equivalent to the G. Q takes the place of the M, and R squared is R squared. And it's that straightforward. The questions are much harder. Have a go at them. Email me if you're having any problems. I'm more than happy to help. And good luck.